All right, for this bell work, we're going to find the slope, and we'll find it two ways. We'll find it first with the slope formula, like this one. Okay, and remember, when we use the slope formula to find this, we'll have to use the x values in the denominator, y values in the numerator for both ordered pairs. Okay, so we have it twice like this. We just got to figure out the ordered pairs that we can use. So it looks like the first one that I see here is this one, which appears to be at -4, -4. Okay, and that would be my x and y values right there. Just to start out, the first value is the x, which is -4. The second value is the y value, which is -4, but since it's the y value, goes in the numerator. Okay, so we're just kind of filling in these blanks, and then after that, we'll put this into the calculator. Now you gotta be careful because the next ordered pair that we see, some students would say that this one would work, but it's not right on that intersection. This one, by the way, is pretty close too, but it's not there, and same with this one. Yeah, this one looks like it's pretty good, actually, right there. Okay, so we'll use this one, which appears to be at 1, 0. So that's our x-intercept. And then again, be careful not to use like this one, or even this one right here where the arrow is, because it only looks like it's going through that intersection, but it is not. Okay, so here the x value is 1, x value is going in the denominator, there it is. The y value is 0, and y value goes in the numerator, so we put a 0 in there as well. Now all I got to do is plug this into the calculator with the n over d button. So n over d, then I type in -4 minus 0, and I go to my denominator, -4 minus 1, and I push enter, and this shows me 4/5 as the slope. So that should be it. But remember, this is rise over run here, which means that the rise would be up 4, and then the run here, 5, would be to the right 5. Up because the 4 is positive, to the right because the 5 is positive. So that also means that from point to point, from the red point to the purple point for me, that means you could have went up 4 here, and then to the right 5, and you would have arrived at that intersection, okay? And whether you're counting lines or boxes is up to you. Remember, you could count boxes 1, 2, 3, 4, and then to the right 1, 2, 3, 4, 5. That would be fine. But you can count the lines as well. So there's the slope in two different ways, but it is still the same slope, 4/5. So keep in mind, yeah, that in the future, just like we saw on a previous homework, that they do not always give us the graph. So sometimes they will just give us the ordered pairs like this, in which case, I mean, you're welcome to graph it. It's just usually the ordered pair is a little bit easier to use. Or the slope formula, it's a little bit easier to use, okay? So, but on the test for this one, from time to time, they will not give you the graphs. They'll give you the graphs, and then they won't give you the graphs. You have to be able to do it. You have to be able to find the slope either way. All right, there's our objective for this lesson. I can graph lines with the slope and y-intercept. Just take 30 seconds and copy that down, please. So finding the slope and y-intercept, that was stuff that we did a lot of there in the last unit, unit 4. So we have to be able to find slope not only from a graph, but also from 2 points by itself, and then also the y-intercept. We can find that pretty quickly if we look at a graph. It's just now we're going to be using this information, the slope and the y-intercept, which may or may not be given. So we may have to find the slope or y-intercept ourselves. But now we have to be able to graph those lines with this information. So just a little information on points and equations. Points that are solutions to an equation make true statements. Okay, so if you go back to this, back to solving equations, what was that, unit 2 for us? You could say, well, 5 does equal 5, okay? So an equal sign, by the way, is a comparison. It's seeing if it is a true statement, okay? And this right here would be a true statement because 5 actually does equal 5. But if I change this 5 here into a 4, all right, then it's a false statement, okay? 5 actually does not equal 4. I can work with it a little bit and say, well, if I wanted to make it true, all I'd have to do is add 1 to that 4 right there. And that's pretty good, okay? Now it's a true statement again. All right, but then we saw that it's possible in an equation to say, well, instead of 4 there, we're going to show an x. And then we say, well, what value of x would make this true? Well, we know from this that if you said x was equal to 4, then you would get a true statement. If you replaced x here with 4, you'd get a true statement, okay? Now what we're saying is, if I replace this 1 here with a variable, like y, then if x is 4, so this is conditional, if x is 4, then y would have to equal 1. Because then in the equation you'd have 4 plus 1, which does equal 5. That would be a true statement. Now there's lots of values. Now that we have two variables, there's actually lots of values that would make this true. For example, you could say that, well, if y is 3, then x could be 2, and that would give you a true statement, all right? But from this, then, you get your ordered pairs. You say x is 2 and y is 3. All right, there's an ordered pair that you could then put on the graph. We also saw, just barely, that if x was 4 and y was 1, then it would still be a true statement. So this would be a point on the line for the graph, okay? So if you were to put this on a graph, like this, here's your x-axis and y-axis, 2, 3, I don't know, we'll put it 2, 3, about right here, and then 4, 1, something like this, okay? Well, that means that you could then connect those dots to make a line. Something like this, okay? But again, the idea here is that you understand that these two ordered pairs, whether it's 2, 3, or 4, 1, would make the original equation here a true statement. Now, most of the equations we're going to see will not be written in this format, but I'm just showing you that what we've seen before, it's pretty much the same idea, but now we're looking for two values to make the equation or a statement true. So they've given us 2 points on this, and we want to just see if it will make the equation true. Again, if it's true, then it would be on the line for the graph for this, okay? So I'm going to go to the original equation, y equals negative 3/4 x plus 8. And for our first ordered pair, they say x is 4, and the corresponding y value is 5. So I just take the x in the equation, and I replace it with 4. Then I take the y value in the equation, and it says in that ordered pair that y value is 5. All I'm doing at this point is seeing if that's going to be a true statement. So I got a question mark over the equal sign. I don't know if this is true yet. But solving, negative 3/4 times 4, that would be negative 3. Then I would have to add the 8, which when I do, negative 3 plus 8, I get 5. So now the statement shows 5 in purple equals the 5 in blue that we solved for, and this is true. Since it's true, 4, 5 would be a solution to the equation. Yes, this would be a solution to the equation, which means if we put this equation on a graph, this point would be one of the points on the line. Now we're going to do the same thing with the other ordered pair just to see if it would give us a true statement. So, go to the original equation, y equals negative 3/4 x plus 8. And here they say x is negative 16, so I go in there and I replace x with negative 16. And then they say that y is 21, and they're big numbers, which is why I like to use a calculator to put the stuff in. Yeah, we just put 21 in there for y. So once again, we're just seeing if this is true or false. So working this through, negative 3/4 times negative 16, that appears to be 12. And then I would add the 8 here. 12 plus 8, it's pretty close to 21. It's just not quite there. It's 20. So now I got 21 equals 20. And last time I checked, that was false. Okay, even though it's close. Still false, which means that that ordered pair would not be on the line. Okay, so here's what this means. So if you were to graph this on a grid here, you got your x and y axis. This line would look something like, I guess this right here. Okay, so this is telling us that 4, 5, the ordered pair 4, 5 would be right on this blue line, maybe about right here. But negative 16, 21, it's pretty close to the line, but it's off the line. See how this orange point is off the line? But the green one is on the line. That would be, of course, the green one again. That would be 4, 5. And then the orange point there, that would be the negative 16, 21. It's not on the line because it makes the original equation a false statement. If you can just understand that much, then you can go very far, not only in this section of mathematics, but mathematics in general, okay? So if you can just understand that there's nothing out of your ability to do. All right, now this is the same thing, just this one's in a different format. This is what we call standard form for linear equations. And we're just going to test these two values to see if they would make the original equation a true statement. So negative 5x plus 9y needs to equal negative 20. So the equation itself is true. We're just trying to see if this particular ordered pair, where x is 0 and y is 9, would be true. So I take the x and I replace it with 0, and then its corresponding y value is 9, so I replace the y with 9. And then again, I'm just checking to see if this is true. Well, what happens here is that the negative 5 times 0 is just 0. So really all I'm looking at is 9 times 9, which is 81. But then the statement shows 81 equals negative 20. Well, that's false. So since it's false, this would not be a solution to that equation. And it kind of looked like it was going to be the y-intercept, but we found that it was a false statement, so that's no good. How about the next one? Well, take the original equation, negative 5x plus 9y equals negative 20, and then we'll see if this is true or false. Okay, so we'll check for truthfulness where x is 4, so I replace the x with 4. And then I replace the y value with 0. Okay, well, 9 times 0, that's going to zero out right there. And so I got negative 5 times 4, which is negative 20. Would this equal negative 20? Yeah, that's true. Since this one's true, I would say yes, this would be a solution to that equation, which means that that ordered pair would be on the line. Okay? Now, on these two problems that we just did, this one and the last slide, they gave us ordered pairs to try. In the future, you're going to have to find your own, and then you're going to have to test those values. Usually what you're going to do is you're going to pick one. So you'd say, I think, let's see what happens if the x value is 0, and then you find the corresponding y value. Or you can say, well, the y value is a certain value, then you find the corresponding x value, which is just solving equations. Simplification with distribution, and then combining like terms if necessary, and then principles of equality to isolate your x, and then dividing both sides by the coefficient, which is still a principle of equality, okay? But I'm just pointing out in the future, you're going to have to find your own, which is where you choose one value and then you find its corresponding value to force this to be true. You'd never just test values randomly like this. So to graph a linear equation, there's only two things that you need. And yeah, we saw that in the objective. And this is where we need what is called slope-intercept form, which I guess we'll see on the next slide. Yeah, there we go. This is slope-intercept form here at the bottom, okay? Okay, now this is popular in mathematics, and here's why. Is because slope-intercept form is going to give you two pieces of information. Although you could say 4. It's at least going to give us two pieces of information. The m is the coefficient of x. It's the number being multiplied by x. That is the slope. Sometimes it will be given as a fraction, which then you would know immediately what your rise and your run is. In addition to that, you see plus b right there. The plus b is the y-intercept. It's just given as the y value. It won't give you the 0, whatever the b value is, as an ordered pair, okay? So the two things you need for graphing straight lines, which is linear equations, is you're going to want the y-intercept, which is given in slope-intercept form, although any point will do. So you don't necessarily need just the y-intercept. Any point that would make the equation true would do. Then you use the slope to find all the other ordered pairs that are on that line. That's it, okay? And it usually goes in this order. Find your y-intercept first, put it on the graph, and then use your slope to find all the other points. But you have to have that y-intercept first. So for this equation, we have to, just throw it away. For this equation, we need the two pieces of information, which then would allow us to graph the line, okay? So remember, our slope-intercept form is y equals mx plus b. So we see that this equation is already in this format, which means that the m here is just this -7. And then the b here is 13. That means that the information was given to us right away. The slope here, -7, that's the number being multiplied by x, the coefficient of x. And then the y-intercept, once again, we don't just put this in as 13, we put it in as an ordered pair, 0, 13. Okay? So if I were to graph this, I would put this ordered pair on the graph first, and then I would use the slope. If it came out as just -7, I would want to show this over 1, so that I can see I would go down 7 to the right 1 from this ordered pair. So if you ever see just integers like this, just make it over 1, so you can see your rise and your run. All right, what about this one? This one now wants us to write the equation where they've given us a slope. So remember, it's going to be y equals mx plus b. And so when I do write this equation right here, all I'm doing is replacing m with the slope, because that's what it is. There's our slope. And then the b here is the y-intercept. Okay, so the slope, I said it's a slope of 2/3. So I just put this fraction in where the slope is, 2/3. That's the coefficient of x. The number being multiplied by x. And again, for the slope, that tells us to go up 2 to the right 3 from the ordered pair, 0, -3. Now we don't put this in as an ordered pair for the equation. You just take the y value, which is showing as -3, and show it as -3 like this. So it reads y equals 2/3 x minus 3. So that -3 comes in as a -3 right there. From what I remember on the assignment, if you put plus -3, I believe it marks it incorrect because it's not considered fully simplified. But that right there, that's the equation in slope-intercept form for this slope and this y-intercept. All right, so once again, we're going to need those two pieces of information from the equations, the slope and the y-intercept, in order to make our graphs. Now, right now, as far as I remember, all of the equations that we're going to be seeing are in slope-intercept form, which is very convenient. Although in the future, we'll have to do some equation manipulation to solve for y in order to force it to be in slope-intercept form. But usually that only takes 2 steps. So here's this equation, right? Y equals -x minus 5. All right, now we want this format to show as y equals mx plus b, like this, right? Where m is the slope and b is the y-intercept. So that means this equation right now is already giving us this information right now, okay? So we say, well, the slope here, the slope is the coefficient of x, which I can see here, it's just showing a -x, so it may help to see this as a -1, okay? Because then I know that my slope here is going to be not just -1, but -1 over 1. Why is that important? Because it tells us the rise and the run. This is a rise of -1, so that's negative, so it's going to go down 1. And then the run there in the denominator is +1, so it's going to go to the right 1. Well, down 1 to the right 1 from where? That's where we need the y-intercept. And we're showing this y-intercept at -5. That's what we need. Of course, it as an ordered pair is 0, -5. So if we've learned what we should have from Unit 4, we know that that's the y-intercept. It's going to be on the y-axis, which is this vertical axis right here, okay? So I say 0, -5. So I start from the origin. I go down 1, 2, 3, 4, 5. And that would be right on the y-axis, which it always should be right here, okay? And then I can label this 0, -5, okay? So I can see my y-intercept. But from there, I'm going to go down 1 to the right 1, okay? And that will give me the next ordered pair. So down 1 to the right 1, so this be this ordered pair, down 1 to the right 1, this ordered pair, down 1 to the right 1. And you can see if I just continue to make this stair step, I get all these points right here in green. Now I can actually go backwards. I can say left 1, up 1, and you see it's the same stair step. That's important because it will give me all these other ordered pairs like this. And I'm not going to label all these other ordered pairs. You could, but this one has quite a bit, so I'm not going to worry about putting the time in for that. Okay, so this one's kind of a big staircase, and once I get all these ordered pairs, all I got to do is graph the line, which I will do now. Oops, that's not what I wanted. There we go, like this. Then I put lines, arrows at the edges to show that this pattern would continue. The staircase continues forever in both directions. Okay, but we found quite a few ordered pairs on this line, which is good because it confirms the pattern. But this equation now is represented by this line. And just so we remember what we talked about earlier, that means that all these green ordered pairs, including the purple one on the red line, that all of these would have made this original equation a true statement. So you could take any random one of these, such as this one, we'll say -6, 1. So if you put -6, 1 into this equation, you'll get a true statement. -6 plus -5 would be 1. Yeah, that's the y value. So see how that all of these ordered pairs make the original equation a true statement. That's important to notice because we're going to be doing stuff with that in the future. All right, let's go ahead and do this equation as well. So let's move that over. Okay, and once again, we're going to compare this with y equals mx plus b. Okay, just like we see here. Well, it's showing the slope. Remember, the slope is the coefficient of x, and remember the slope is the coefficient of x. So there it is, m. Is there a coefficient of x in the equation? Sure is. It's a fraction already for us, which is very nice. I can see that the slope here is 3/5. So since both of these are positive, that means the 3 is positive. That's our rise, so it's going to go up 3. And then the 5 is also positive, so that will go to the right 5. Okay? Up 3 to the right 5. From where? Well, that's the y-intercept. So it's going to be an ordered pair, 0 something. Well, we can see there that the plus b part in the equation is that plus 3. So that means it's a positive 3 y value. So let's go ahead and put that on the graph, 0, 3. So I start from the origin. I know it's on the y-axis, so I'm just going to go up 3. 1, 2, 3. And that would be my ordered pair right there, 0, 3. Now I'm going to use the slope to find all of my other ordered pairs. So this is showing up 3. So I go up 3 here. And then to the right 5. And that gives me my next ordered pair. And just like we saw on the bell work, if you need to be counting the boxes, then do that. You can count lines as well, okay? There's my next ordered pair. In fact, I can actually go up another 3 and then to the right another 5 on this graph to fit this ordered pair in there. But, like I said before, I can actually copy these backwards, so I'd go left 5, down 3 to create the other stair step, and then left 5 and down 3 as well, to give me all the ordered pairs on the graph. Now that I have this, I am ready to graph the line. There it is. That looks pretty good. Okay, so that red line represents that equation, y equals 3/5 x plus 3. So before I do the next couple problems, I'll just emphasize this. Okay, the 9th grade teachers pretty much say that if you can't do this stuff, that you pretty much won't be able to do anything in 9th grade. Okay, so if you guys are going to struggle with this and choose to struggle with it, never ask questions, never do the homework or anything like that, or take notes, then just don't expect to be able to do very much math here in the future. But if you can do this, then there's pretty much no limit to what kind of math you can do. You can do calculus with this kind of stuff. You can go as high as you want, okay? But you have to be able to do this stuff. All right, here's next equation. Take a minute, try this one out. Y equals -2/3 x minus 3. and we'll go over it. So this equation, I'm going to start with the y-intercept on this one because it doesn't really matter. All right, but remember the y-intercept is the plus b part. Now this one showing is minus 3, which in the ordered pair for the y-intercept, it just makes the y value a negative. Okay, so 0, negative 3, that would be this ordered pair on the graph. See if I can do that a little better. There we go. Okay, so this is the ordered pair, 0, negative 3. Well, what am I going to do? From there, we got to figure out the slope. Okay, and the slope is showing as the coefficient of x. So what's the coefficient of x in the equation? It's negative 2/3. Now for me, I always like to put the negative with the numerator because I like my denominators to be positive, if I can. It would have been okay, by the way, to say, well, it's positive 2 over negative 3, which was just up 2 to the left 3, if it's necessary to do that. Okay, but this one looks like it's good. The 2 is negative, so I will go down 2, and the 3 is positive, so I'll go to the right 3. Down 2 to the right 3 from our ordered pair that we already have on the graph. The y-intercept, so down 2, so that's showing there, down 2, and then to the right 3. That gives me my next ordered pair. Like I've shown before, there's actually enough space to go down 2 to the right 3 again, and then even one more time. Okay, so that's my other ordered pairs, all of which would have made the original equation a true statement. All right, now I'm going to copy these stair step backwards as well. So left 3 up 2. So that's my next ordered pair, left 3 up 2. And again, I'm just continuing this pattern. One more step I can fit on here. There it is. Okay, so there's all the ordered pairs I can fit. Then I'm ready to draw my line, something like that. Okay, so that red line represents that equation, y equals negative 2/3 x minus 3. We started with the y-intercept, then we use the slope to find the other ones. Now, just so you know, on Canvas, they have the tools for you to be able to graph these. So you only need 2 points, though, in order to graph these lines. So you just put, you'll click on like a line function. Then you put one ordered pair on the graph, and then you put the other one on the graph, and then it creates the straight line for you. So you won't have to draw these by hand. Canvas will do that for you, just very convenient. All right, how about this one? Y equals negative 3/4 x. Well, let's see. Okay, so there's our equation. Remember, we're looking for y equals mx plus b stuff. That looks like it. That lines up pretty good. All right, now on this one, we do see the slope on this, right? Remember, the slope is the coefficient of x. There it is, negative 3/4, okay? Now, a lot of students ask, well, what is the plus b part of this? Because it's not being shown. That's one of those phantom plus 0 values. It was there the whole time, you just couldn't see it. So if it helps you to see that, then show it, okay? So for me, I'll start with the slope here. Again, we're showing that as negative 3/4, so negative 3 for my numerator, positive 4 for my denominator, which then tells us that when we start graphing this, we'll have to go down 3, that's my rise, and then my run is to the right 4. Down 3 to the right 4 from the ordered pair for the y-intercept. So remember, that's the plus b part, which is showing is plus 0. There we go. So that would be the ordered pair. Remember, the x value is always 0, but now it's showing the y value also at 0. That's the origin right here, okay? So we can put the origin on this 0, 0. All right, but from there, I'm going to use the slope to find the other ordered pairs. I'm going to go down 3. That's what it said in the slope, down 3, and then to the right 4. That gives me my next ordered pair. Okay, but I'm going to continue that pattern. Down 3 to the right 4, boom, there's this next one. And then I'm going to go left 4, up 3 to find my other ordered pairs on this one, left 4, up 3. Again, I'm just copying that stair step, that's it. Now that I have all the ordered pairs that I can fit on the graph, I'm ready to, well, start graphing this with the line. There we go. So this one is going straight through the origin, which I think you guys saw a little bit of in 7th grade, but that was a long time ago. No one really remembers any of that garbage anyways. So there's our objective. Again, you saw in all the equations that gave you the slope and the y-intercept, which then allowed us to graph those lines. So I hope you feel pretty comfortable doing that from now on.